getting tenants that are attracted to have digital buildings, and it provides automated system improvements. So just a brief history of converged IP networks. Back in 1995, basically the only types of networks that we had were voice and data systems. We were running on UTP 4-pair cabling. And then up in 2005, we went to Wi-Fi, we went to wireless communications, also added video surveillance and access control. And then in 2010, we added access, our building management systems. HVAC systems were added to the internet. And then in 2015 and 2018, we added sensing. PoE lighting was added in 2020. And AV over IP was added as well. So everybody's familiar with all these types of connectors that we utilize. We have UTP connectors, we have HDMI, we have optical audio connectors, we have power connectors, we have audio video connectors, we have RS-232 connectors, and we have HDMI connectors. So what we can do now is we can throw those all in the garbage, and we can change everything to one type of media, which is an RJ45 connection using a 4-pair UTP cable. Excuse me. So in the past, all the different building systems were autonomous. The security ran on its own network. The building automation systems ran on their own network. Communications ran their own network. They're all operated in silos. Today, we're going towards a converged building system. So we have sensors throughout the building, and these sensors create data. The data provides information, and the data center collects this information, and this is all done by created through a PoE switching. So this is basically a schematic of how this all works. So we have security, we have building automation, communication, building management systems, and these always previously used to work in silos. And now how they're all working together is a good example of this. If we went to presence, we have sensors in a room that can detect if somebody is present. And once we detect that there's an individual present in a specific room, it activates lights. So the lights automatically come on. It activates climate control. It'll turn down the temperature to a specific degree, and then people will accumulate into this building or this specific room. And as people gather, obviously the temperature is going to rise in that room, and then what sensors will detect the temperature rise, it'll turn on the air conditioning. So these all systems are all interconnected through a PoE system. And they all talk to one another. And this is just a diagram of how these systems communicate and talk to one another. In the past, as I mentioned previously, these are all disparate systems operating in silos that would not communicate. Now they all communicate and work together on an IP-based network. And the benefits of converged building is it simplifies building systems management, improves energy management, efficient use of real estate. It's a competitive differentiator. As I mentioned before, it attracts a talent. People are willing to work for people that have a digital building that provide all these services. And if you are a building owner that rents out space to tenants and whatnot, you're going to attract tenants to these buildings by offering these types of services. And you can generally attract more money or get more rental income as a result of this. So the foundation of a digital building includes applications, control systems, network infrastructure, structured cabling. The different applications include, as per this diagram. So it all starts on your right at the telecommunications room or the data center for that matter. We have a PoE switch that delivers power and data to all these devices that are in this huddle room or this conference room. And different examples of this include a wireless access point. It could be a security camera. It could be an AV screen for audio-visual purposes. Building automation systems on the left screen, so you can control temperature and whatnot through that. We have wall outlets that provide PoE, and with PoE now we can actually generate power to generate through a UTP cable. We can power up a laptop. So one cable, like one patch cord, for example, can power up a laptop. We provide data services as well. Excuse me. So all these services can be delivered under one common media, which is a 4-pair UTP cable delivering data and power to all these services. And if I just go back to this, to the right, to the telecommunications room, so we have all our UTP cable going up into a edge switch and a patch panel, and then we use this as a consolidation point, and then we can distribute all of our cabling to all these different devices that are in this particular room. PoE requires a high quality infrastructure. Excuse me. It's been said that the Gartner Group has done a study and indicates that 60% of network infrastructure problems are directly related to physical infrastructure and its connections. So And Gartner, our land technologies, also indicated in their studies that 70% of all network failures are attributed to network cabling. So 60 to 70% of all network issues can be related to structured cabling issues, which is basically your cabling and your connectivity. Passive physical infrastructure typically represents less than 5% of the total capital expense of any network project. So when you're looking at all the elements of your network project, infrastructure, your cabling and your connectivity represents the lowest cost of all your components that are required for a network. Your hardware and your software represent the largest portion of your costs, even though your connectivity represents the lowest portion of your costs, represents the highest cause root of your problems, of your issues. So some things that you must be considered when designing an IP network is temperature rise in bundles. Now that we're utilizing PoE technology, we see a rise in temperature within our cable bundles. And generally speaking, EITI recommends that no more than 15 degrees Celsius rise in the cable temperature of the cable bundles is permitted. You also have to consider whether we use category 6A or category 6 cabling. Actually, PANDIT recommends category 6A cabling be used because it offers the broadest bandwidth and it's the best performing cable in terms of temperature rise. And a new development in the U.S. is a type of cable rating which is called LP cables, which stands for limited cables. It's not prevalent here in Canada yet, but it will be soon. It's part of the National Electrical Code in the U.S. and it will be something I'm sure that the Canadian Electrical Code will be adopting in the near future. So what limited power cables means is that the amount of cables that you can bundle in a PoE application is dependent upon the amount of heat that these cables will generate. So in the past, in order to calculate how many cables you can put in a cable bundle, you had to use an amperage or an ampacity table. And based upon the current that is being, the amount of current that the cable is able to run and the amount of current that's required to operate that device, use that chart to calculate how many cables you can put into a cable bundle. And based upon that chart, it calculates what the temperature rise was, and then therefore you can calculate how much cables you can put in there. But with an LP cable rating, you can put as many cables as you want in a cable bundle. It's been pre-tested and determined that you can put as many cables in a cable bundle and not have to worry about heating issues. Another issue related to PoE and connectivity is arcing in the jacks. Every time that you disengage a patch cord from an RJ45 connector, a spark occurs inside the connector itself. And what happens when this arcing occurs, there's a carbon buildup on top of the contacts inside the jack, the RJ45 jack. And over time, as this carbon buildup occurs, it could result in connectivity issues between the jack and the plug. And ultimately, network performance issues will occur. So you have to take that into consideration as well. Also, another consideration that must be involved in the decision-making process is whether to use 23 or 24 gauge copper cables. It's recommended that 23 gauge copper cables be used because the larger the copper within a copper cable is the more current that cable will carry. So it's advantageous to use a larger copper conductor when it comes to using any UTP cables. Another issue related to using these the PoE into automated buildings and intelligent buildings is now that we're incorporating a large number of intelligent devices, there's going to be a lot more ports, a lot more cabling that's going to be involved. And if it's an existing building, in most cases, our IT infrastructure is not given a lot of attention when the building has been designed. Typically, the other utilities are given more resources and more space within a building. The electrical rooms, for example, the rooms for distributing water and so on and so forth, they're given more priority and given more space. And any space that's left over in a building construction is left over for IT. And typically speaking, that's not a lot of room. So with this high density cabling that's required to support all these intelligent devices that are being utilized today, we have to be a little bit more thoughtful on how we're going to use our space within these organizations. So you have to start using some high density solutions that will increase your capacity, such as zero RU patching, Zero RU patching, there's our patch panels that can be vertically mounted in a rack as opposed to using a horizontal space that frees up space for other active equipment. It's like just switches and servers and so on and so forth. Now we can use one-to-one patching as well. One-to-one patching will allow you to directly patch above or below a switch or a server into a patch panel as opposed to horizontally routing your cabling down to a vertical patch panel and then horizontally routing it again into your or to a switch. So now you can directly patch using shorter patch cords above or below the piece of equipment that you're trying to patch. And what that does, it eliminates the need for more vertical cable management. You can use small diameter patch cords as well. These are 28 gauge patch cords, which are approximately about 60% the size of a normal patch cord. And again, they're very great for reducing space requirements. And also you can use high density patch cord or patch panels. For example, you can use a 48 port patch panel that will occupy a 1U rack space position in a rack. And typically in most patch panels, a 48 port would require the use of a 2-port patch panel or 2 rack space patch panel. Excuse me. Also, other things to consider is the direct connection of equipment, horizontal distribution, electrical arcs disconnecting devices, and thermal dissipation into powered cable bundles. And I'll get into those in a little bit more greater detail. And again, when it comes to bundling cables, when we're running power through it, the heat that is concentrated is going to be in the center of the cable bundle. So it's best practice in general is no more than 24 cables in a bundle. That's 24 cables in a bundle. However, if you want to use an ampacity table, you can actually, if you want to do the math, you can calculate how many cables you can use. Or if your cable has an LP rating on it, you don't have to worry about that, and you can put as many cables as you want inside the inside your cable bundle. And again, as I mentioned previously, the arcing that once a female or a male plug is removed from a female jack, there's an arcing that occurs that it will cause some scarring or some carbon buildup. And you have to be mindful of that. And just to let people know that what Pandor's designed their connectors so that when a plug is removed from a jack, the arcing that does occur is removed from the point of contact where the jack and the plug mate. So any scarring will not result in any disconnect between there still would be continuity between the plug and the jack. It will not have any interference in terms of the communication or the transmission of data between the jack and the plug. Another thing to consider as well, if you want to use a consolidation point or use a direct connection, structured cabling is exactly that. It's a structured approach to introducing your cabling into a network. And why we use structured cabling is it facilitates the ability to make moves, edge, and changes a lot easier. So a structured cabling approach generally involves different components. So we have a telecommunications closet, and then we distribute our cabling horizontally to different devices that are on a horizontal plane or a specific floor within a building. So we would have a patch panel that would distribute our permanent link or horizontal cable to different parts of the room, to different devices. It could be a computer, it could be to a different device that's on a floor. And that requires the use of the patch panel also requires the uses of patch cords. However, EITI now allows the use of direct cabling. So a good example of that would be, let's use an example of a security camera. So a structured approach of that would be using a patch panel inside of a wiring closet. We would use permanent link or horizontal cabling into a surface mount box or another patch panel that's going to be in a plane of space or above the ceiling. And then we use a patch cable from that particular patch panel into a camera. And that's what we call a structured approach. But now EITI is allowing the use of direct cabling. And what direct cabling would involve would be going from the telecommunications room, using a permanent link cable, and you can terminate directly into that device, whether it be a camera or an access point. So it does not require the use of a secondary patch panel. It does not require the use of another patch cord. So it's more cost effective in that effect. But again, it's limited. If you want to make any additional moves, edge, or changes, you're kind of restricted. You're going to have to pull additional cables out, and there's a more cost to that. So there's advantages and disadvantages of using a structured approach or using a point-to-point cabling system. For converged networks, again, it's recommended that 23 gauge cabling be used. And again, the reason that we're using 23 gauge cabling is because you can increase the current that is able to be run through that cable more so than a 24 gauge or 26 gauge cable. And all Panduit Category 6A and Category 6 cables utilize 23 gauge cables. Again, it's recommended that we use cabling that has LP ratings. Again, all Panduit Category 6A cables have an LP rating on it. And then most of our Category 6 cables have an LP rating as well. It's recommended that we use high temperature connectors as well. Panduit connectors have a temperature rating of 65 degrees Celsius. And disconnecting plug with live PoE, and that's the reason that we have third-party certification that indicates that once you do remove that arcing that does occur within a jack and a plug, the arcing does occur away from the point of contact between the jack and the plug where the data transmission does occur. So where does Panduit fit in? Of course, we make patch panels, the copper cabling, the connectors, the plugs, the field terminable plugs, J-hooks, cable trays, enclosures, racks. We provide all the infrastructure that ties it all in together. We have the telecommunications room, 20 gauge patch cords. And the picture on the right just shows you the difference between the small diameter patch cords and the regular size patch cords. Again, they're about roughly half the size of a standard patch cord. This is our Very Matrix cable. It's our Category 6A cable. We call it Very Matrix because it has a matrix tape that surrounds the 4 pairs of the cable. And the benefit of those 4 pairs is when we're running 10 gig applications or Category 6A applications, we're doing duplex communications. We're sending and receiving data in all 4 pairs. So we're sending and receiving up to 250 megabits of data on each pair times 4 for a total of 1 gigabit. And because of this, what happens is that we have signal coupling internally between pairs within the cable. And to avoid this, what Panduit has done, is other manufacturers have done this as well. Not only do we have signal coupling between pairs within a cable, we also have signal coupling between cables themselves. So what Panduit has done, and again, other manufacturers have done to prevent a cable or signal jumping from cable to cable, is they surround the 4 pairs with a matrix tape. So what that does, it just prevents signal coupling from cable to cable. But the secondary benefit, and probably the most important benefit of it, is it suppresses, it dissipates the heat a lot better when we're running for PoE applications. We have angled patch panels. Angled patch panels are ideal for eliminates the need for horizontal cable managers. Field terminal plugs, these are good for point-to-point cable terminations. So again, you can go from a patch panel directly into a remote device, such as a security camera or an AP, wall mount enclosures, vertical, horizontal cable managers. So where do you put all the PoE? So PoE is used for wall switches, lighting applications, different types of sensors, whether it be proximity switches, whether it be for sensing people within a room, security cameras, digital signage, all connected by reliable, future-proof infrastructure. So Panduit offers all the support and requirements that are needed for future-ready to converge PoE network, a seamless integration between IT and OT, and it's the foundation of the digital building. Any questions?
Anybody have any questions for Greg? That was really informative, Greg. There's a lot of information. I have a couple of questions here, if you'd like to
Sure.
take one. And if anybody wants to ask the question, if you want to unmute yourself, we could. That would be great. So basically, I know we had a few engineers that weren't able to make the meeting, but they did have a couple of questions they wanted answered. How will the latest cabling standards and technologies impact the category of copper cabling utilized?
Again, I think it's because we're running PoE and a lot of these technologies are requiring additional bandwidth. It's recommended that Category 6A cabling be used. So it's also good for future proofing. So it's highly recommended as a minimum that Category 6 cabling be implemented and deployed for any new design. But ultimately, it's highly recommended that Category 6A cabling be used. And again, that's for 2 purposes: for additional bandwidth and also to help suppress the additional heat that's incurred by using the PoE technology.
Mhm.
There is an additional cost to it, unfortunately, because plenum rated cable, especially Category 6A cable, is quite there's quite a difference in cost between Category 6 cable, but the effect on future requirements and also network performance, it's worth the payback.
Absolutely. Okay, thanks. Um, so you talked a little bit about the PoE lighting, and I know that we are looking at maybe putting on another webinar for this, but how do you feel that the PoE lighting will impact the cabling industry?
It's huge. I think it's an emerging technology. It's something that's going to be, I think, in the future, all buildings are going to embrace and incorporate this technology. It's actually Canada's leading the way, I think, globally in terms of the digital building, namely in PoE lighting as well. I think one of the first adopters in North America was Cisco, with the new Cisco Canadian headquarters in Toronto was a world-class building, and one of the first in North America to adopt this type of technology. And then something we are proud to be about in locally as well as in Nova Scotia is in last year the new Amira building downtown Halifax. That's all PoE lighting as well, and I think we're going to see more of that. And because of that, I know that specifically the Amira building, or the Nova Scotia Power building on Terminal Road in Halifax, that's incorporated. The PoE lighting is one of the showcases of that building. And I think that's got something like 30,000 data points in that building. And of course, every one of these data points requires cabling. So it's definitely going to have a major impact in terms of the amount of cabling that's going to be used. And a lot of people, when wireless was introduced and that technology was adapted in the marketplace, a lot of people thought that cabling was not going to be required. There wasn't going to be much of a need for cabling anymore. However, now the opposite is occurring. There's going to be more and more cabling is going to be required to support these new technologies, these new devices, these new intelligent devices. And of course, PoE lighting is going to be a major component of that.
That brings me to kind of another question. I know there's an awful lot of talk about the intelligent buildings and that kind of that trend, with the PoE lighting and everything as well too. Do you find the Maritimes, they usually tend to be late adopters. Do you find they are adopting this idea, or are they still kind of staying away from the new technology?
I think it's still in its emerging stages. Where I see it happening is some of the larger corporations that have the resource to do it. I'm seeing that happening, but I think as it becomes more affordable, as the cost of the devices come down and whatnot, I think it'll be more a higher adoption rate. I think it's becoming more. At the present time, I think there's a bigger opportunity, specifically in Atlantic Canada, more on the industrial side of that, because I think the economies of scale, the payback can be paid, determined a lot more quicker by the OT side of things, by improving the efficiencies in the manufacturing process, by adopting IP Convergence on the plant floor. It just improves the manufacturing process, reduces costs overall. So I think there's a better economic footprint on the industrial side, but I think on the enterprise side, on the digital building side of things, I think it's going to be something that people are going to adopt. But I think people that are going to adopt are going to be doing it for two reasons. Number one, like I mentioned, it's going to create a happier workforce. People are more happy when they have a more satisfying work environment, when they can more comfortable, the more resources that are available to them. They can communicate a lot better. They can collaborate a lot better. Just the environment that they're working in is a lot easier in terms of the lighting. They can adopt or change the lighting atmosphere to something that they're familiar with. They can control the temperature and so on and so forth. And also people that building developers, property managers, people that build buildings, and with the intent of leasing space out to them, they're going to find that they're going to have more people are going to be going towards their buildings as people that haven't adopted this type of technology. So I think eventually we're going to see more and more of this technology developed.
Absolutely. Now, I know we do have a few electricals and engineers on board as well too. And do you have any recommendations when they're looking at rolling out any designs or on their drawings or anything that they could provide that would help their customers design on, like, how to better consult them, right?
Absolutely. I mean, Panda's got a lot of resources that we can do. We have proof of concept. We have um, white papers that we can use that help them, design their network infrastructure. We actually put on courses for people that they can attend and how to. What I'm finding is a lot of people are very good at developing the logical design of a network and whatnot when it comes to IP convergence, but they have trouble adopting or converting the logical to the physical, and that's where Panda can help. We can help you. We have subject matter experts. We have system integrator engineers, our technical experts and whatnot that can help that. And as I mentioned previously, we put on courses that teach people how to transfer the logical and transfer it to the physical and whatnot. So, and there's also a lot of resources from EITIA and different organizations that can help you with this type of design.
Mm-hmm. Absolutely. Well, I know working with our designers, they usually do have quite a few questions when we're putting out information like quotes and stuff like that or proposals, right? Because it's really important that we get the accurate information so that we can give the proper recommendations and work alongside of your teams. But yeah, okay. Well, that sounds great. Does anybody?
Yeah, I do actually have a question. Thanks, Greg. Very good presentation. Firstly, I was just wondering if you could actually do a two-part question. They are separate questions, but I guess my first question was, I'm wondering if you, or I guess, could you speak a little bit about the lack of the derating in the LP cable? I guess is the first thing I would like you to speak about. And the second piece the second question, or second piece that I would like you to talk about, if you could. In your presentation, you outlined about how structure cabling is one of the longest pieces of the whole total system. And what I'm trying to get my head around is that in a hospital environment, there is numerous structure cabling, as you can imagine, and there's some debate on the amount of cabling needed for these environments. And so, with that being said, I guess the second part of the question is that if you could you speak a little bit about structure cabling and the layout and design in the hospital environment and going forward on new builds? And if that's not possible, that's fine. But just I kind of want the first one was really the real question. The second one, if you could, that would
be. I'm sorry that you were cutting out there. What was the first question? I realized that it involved cabling in a hospital type of environment.
No. So the first question, Greg, was basically just the LP cable designation. You said that you could bundle, there's no maximum, and doesn't derate, as in, like, obviously it must be for the cable tray. I don't know. I'm not familiar with this new LP cable. I'd like you to speak a little bit about how it got around the derating factor and how that, is it because of the mesh that you had spoke of? And maybe you can give us a little detail on how that in the new code for CEC, we're coming out in 2022 is the new code coming out. How would that be incorporated for the derating factor for percent conduit fill or for cable tray fill or the wire bundling itself?
Okay, like you mentioned, the LP rating is something it's U.S. is basically national electric code in the U.S. So, again, in order to determine how many cables you can put in a bundle by using PoE is dependent upon how much power the end device, the intelligent device requires, and how much power or current that your cable is allowed to use. And so there's an ampacity table that you use to do those calculations. You derate it and calculate, okay, based upon my cable, the particular cable that I'm using is suitable for this much current. The intelligent device that requires this power requires this much current. So based upon this, we can determine how much cables we can bundle together without affecting the performance of the cable. So what happens is when we put too much power, we generate more heat. And what happens when we have too much heat in the cable bundle, it interrupts the network transmission, and it also can damage the cables themselves. So what limited power rating, what that does is you don't have to do that calculation, and then you can put as many cables as you want into a cable bundle. What Panduit has done, we've tested up to 100 cables. So You could probably go beyond 100 cables. What we recommend is 100 cables in a bundle. We've actually tested it. We've done the temperature readings. We've manufactured a jig, and we've put 100 cables together. Then we measured the temperature in the center cables of that jig, and it all was compliant. It was no more than 15-degree temperature rise in that temperature or in that cable bundle. So
was there
that's
standard length, Greg? Was there a standard length that you guys used? Was there a standard length? Because obviously voltage drops depend on length.
We actually use 26,000 cable runs to do this, different types of cable configurations. Some cable runs were, could have been 100 feet, and all the cable runs were up to the maximum, which is 100 meters or 330 feet. So nothing beyond that. But yeah, we configured this in different scenarios using different types of cable distances and whatnot. So we used every different scenario imaginable in order to get an appropriate reading on this.
So when we get that in Canada, you said it's national electrical code down the States. Is that going to be adopted into the CDC under this new code cycle?
I believe it will be. I mean, pretty much any change in the electrical code that occurs, most of them, I would say, occurs in the U.S. first, and then usually a year or two after that, Canada adopts it. So this came about. The limited power came about in late 2018, I believe it was. So I suspect, and I know that the National Electrical Code or the Canadian Electrical Code, they don't publish a new book. Correct me if I'm wrong. I don't think it's published every year. I think it's every other year.
Yeah, well, 2022 is the next cycle. It goes every 3. It was going for 4, but it went back to 3, and now it's on 3 every cycle. So I think 2022 is what they're talking about now because they had to do a rewrite on Section 10. So that was such a big rewrite that I think they're going to publish 2 years this time, and then after that they're going back to 3 years. Just because of the code cycle, so many changes. We had like 240 last cycle. I think the cycle before that we had 260 or something. So.
So I would say probably the next Canadian Electric Code is issued. I suspect that'll be issued on there, and then to know if a cable has limited power rating on it, it's going to be stamped on the jacket of the cable itself, so you don't have to do any investigation or ask the manufacturer or whatnot. The manufacturer will stamp it on the jacket of the cable, so you will know that's on there.
I see it useful in renovations because sometimes our cable trays, we try to clean out as much as we can, get the contractor to clean it. You can't trace everything, so we can't pull everything. So that's a big thing. So then if we can cut down on the bundling of it, we don't have a maximum, we don't have to break them out in groups, which is kind of nice. That was interesting. I didn't even know that existed.
Okay.
How about the hospital infrastructure? Can you speak to that a little bit about building the hospital in Halifax? So how about that a little bit? Can you speak a little bit about the infrastructure design for hospitals for Panduit? What you guys put out for hospital equipment?
For network infrastructure for hospitals, yeah, we have subject matter experts specifically for different markets, including hospitals. So we can we have best practices. Hospitals are definitely a different beast than any other project and whatnot. Yeah. I mean,
we have public people ourselves that are doing a specific group. We have an IP infrastructure group that's just for hospitals, and we've been meeting on it because of rewriting the DC 350 for hospitals, and that's one of the structured cables that's been coming up. We've been meeting on it, so that's kind of where nothing's been decided or anything. It's still very, very, very open, but it's just I want to just try to basically numbers.
Yeah, it's the same thing. It's just like we like if you're interested, we have a presentation specifically on infrastructure specifically to the healthcare industry. What's recommended, what types of solutions that are recommended for the different systems, because there's so many different systems that are incorporated in the healthcare environment. You have nurse call stations. You have there's just numerous different systems.
Doctor scan, they have all the patients' medical records all online. There's many systems that are incorporated. That's why I'm trying to figure out about the structured cabling. Can we redundantly reuse some stuff, or can we double? That's what we're trying to figure out is how much structured cabling do we actually need, and how much space do we have to account for this area.
Exactly, and also you can use wireless systems too, because when nurses or doctors go into a patient's room, they can document any changes in their medication or their vitals and whatnot. They can do it instantaneously on a tablet, that type of thing. So there's different.
They use it as a subsidy to the actual infrastructure, because as you spoke about it, when Ontario rolled out Wi-Fi, Nova Scotia, for our school program, there was a lot of debate on, was it healthy for the kids? Is it secure? Is it net? And so they wanted to eliminate as much infrastructure as we could. And we did cut down our room data sheet quite a bit, actually, for our classroom layout. We actually cut our cables by half, and you relied on Wi-Fi, but we had talked about going a complete Wi-Fi system for a school, but that just never came about. We just never went that way. We just decided to cut it in half and cut down the cost to try to save money, but use that, but don't still have some infrastructure in case the Wi-Fi failed,
right?
Mm-hmm. Excellent.
So did you guys, I know the province of Ontario has a standard, like an infrastructure standard specific to hospitals. Is that what you guys are creating as well?
That's correct. Yes, sir, Greg. Yeah, so we've been meeting on it for the last 5 months. Ian is running the show for it. David, I, and Greg. Well, Greg left; he went over, and then Jim came. He's gone now too over to hospital. So we got Jason and Minna. So there's 4 of us, and we're kind of working on that. And we're all home, so it's a little harder now because we used to have internal meetings, but we don't have. Well, we're having them via this, right? And so it's harder now. But yeah, they're still working forward. But like I said, I'm on the outside of it, looking in kind of. That's higher level. That's above my pay grade. So those people are making.
But like I mentioned, I mean, if you're interested, we can do, I can get our subject matter experts involved, and we can do specific to healthcare. We can do a best practices and what Painter recommends in terms of infrastructure for the healthcare industry. If that's something of interest, we can certainly, present you on that as well.
Well, I know Minta George just came with us. He left. He was at WSP, so Minta's our new senior for health. So I'm sure Minta will be sitting on that panel with Greg McGrath and Jim Teakston for the election.
Okay.
Yeah. So yeah, maybe if you know Minta, you can reach out to him. He might be, or I'll tell him to maybe reach out to you too, Greg.
Nope, absolutely. Be more than happy to do something like that.
Yeah, and maybe we can add that as one of our educational webinars too. I do have another question. Thank you, Eric. Those were great questions. I do have another question here from Anthony. With more and more industrial machines being connected to the IoT, what differences are you seeing in the design versus the standard office environment?
Well, the main difference between the enterprise environment and the industrial environment is just the specific environment that it's in. An enterprise environment, obviously, it's a controlled environment. There's nothing harsh about it. You can control the temperature. There's no harsh chemicals. There's not a lot of noise being introduced into the network and so on and so forth. It's more of a calm environment. But however, when we got into the industrial side of the or the manufacturing process, like I mentioned, we got a lot of noise being introduced. There's vibration taking place. There's dust. There's water being introduced. There's all kinds of nastiness taking place, for lack of a better word. In order to mitigate a lot of this nastiness to incorporate into the network, you create a hardened product. So a lot of the products that you have to incorporate are like hardened cables. There's hardened switches that are used, products that have an IP rating on them. And what Pandard has done is we created what we call a MICE table or MICE chart, which stands for Mechanical, Aggression, Climatic, Environmental. So we rate all of our industrial rated products on a scale of 1 to 3. Where 1 would be the least harshful environment would be, I guess, like in an office type or commercial enterprise environment. Number 2 would be a somewhat of a more harsher environment. There could be high temperatures involved with it. So we have products that are rated for high temperature environments. And then obviously a very harsh environment could be something that's just high temperatures. There could be chemicals that are being used. It could be a washdown environment. It could be, like an example, an agricultural producing a dairy plant or something that all the equipment has to be washed down. So all these products have to be rated to withstand these type of environments. So that's the main difference between the 2 types of enterprise class and industrial class products. So it's more of the rating that's ability to withstand these type of environments.
Mm-hmm. Great. Good question, Anthony. Now, Dave, did you have a question?
Yeah, so if we, we deal with a lot of customers that are in the manufacturing and industrial environment. Do you see a lot, like the trend between fiber versus copper in that area? Do you see the trend gone more to the fiber area?
It depends. I think still copper is pretty common. Fiber in the industrial type of environment is really good because it's immune to any EMI or noise. So for those type of purposes, applications, I would recommend fiber be used. And the second reason I would use fiber is for distances. A lot of plants that your manufacturing facilities are fairly large, and with fiber you can run larger distances. So you can go like multi-mode fiber, you can run 2 kilometers without any repeaters regenerating the signal. Like in a single mode fiber, you can run up to 3 kilometers and so on and so forth. So I think copper's still pretty common, but other than the fact that when you have environments where there's going to be a lot of noise introduced into the network, you might want to consider fiber optic cables, or again, for distance purposes, you might want to consider fiber. But I still think copper is probably the most common type of media that's used in the industrial environment.
Okay.
Excellent.
Thanks.
All right. Did anybody else have any questions?
Hi, it's Anthony Desmond here with Irving Shipbuilding. I do have a quick question, if that's all right.
Yeah, absolutely, Anthony.
Okay. So obviously the trend toward powering devices over PoE is really exciting. There's only one thing that scares me. Power failures are obviously a huge showstopper for any business or institution. If PoE is going to be utilized for like supplying significant amounts of power to end devices such as computers, controllers, light fixtures, how do you prevent short circuits or downstream equipment from causing significant damage to the distribution racks? Because, I mean, I know you mentioned thermal disconnect technologies are in place, but what happens when a short circuit triggers like 10,000 amps instantaneously? How do you prevent the patch panels from sustaining catastrophic damage to that?
That's a very good question. And I don't have the answer to that. I'd have to look into that and get back to you on that one. But that's a very, very good question. To be honest with you, I can check with our product management team, our subject matter experts, and I can get back to you on that.
Yeah, sure. Yeah, I'd be interested.
Yeah, I'll definitely get back to you on that.
Perfect. Perfect. All right. Any more questions? I think that might be it. I think we've discovered a couple of new hot topics that we might be able to discuss. I know me and Greg will be meeting on Friday to discuss maybe another webinar or two. And if you guys have any suggestions before then, please send them through, and we'll make sure to address them and put some things together and keep everybody posted as well. So first of all, I'd like to thank you, Greg, for taking the time to present to our clients and our partners. And it was really informative. There's lots of stuff to learn. It's nice to know where the technology is going as well too. So anyways, I think that's it. I think that's done for today, guys.
Great.
Thanks for joining. I really appreciate you taking the time.
Thank you very much, guys. That was really excellent.
Excellent.
Thanks, everybody.
All right. Have a great day.
Thanks, everybody.